All right, let's look at section 4.5, how to determine whether a pair of events are independent or dependent, and then find a probability. So we want to know if these two events are dependent or independent. When a baby is born, it's a boy, and then when a seven-sided die is rolled, the outcome. Two events are independent if the occurrence of one does not affect the probability of the occurrence of the other. If a baby is born, is that going to affect what you roll on a seven-sided die? I don't think so, right? So they're completely independent of each other. The outcome of one has nothing to do with the outcome of the other. When you have independent events and you want to find the probability that both A and B, so in other words, both a baby is born and it's a boy, and then we rolled a 2 on a seven-sided die, whenever we want to know that they both occurred and we have, if you remember, I mentioned the word or in probability says to add the probabilities. In the word and in probability means to multiply. If they're independent, you just simply take the probability of the first event and multiply it by the probability. First event, probability of having a boy, 1 out of 2 ways to have a boy, times the probability that you roll a 2 on a seven-sided die. There's only 1 2 on that die. Multiply those, I get 1 over 14, or I change it to an actual decimal probability. So if they're independent and I want to know the probability that these two events both occur, I just simply multiply. Now your textbook mentions this 5% guideline. Basically what this says is if you have a large sample and it's what you're looking at is no more than 5% of the population, you can just simply treat it as, let's look at an example and test that. So it says when a page is randomly selected and ripped from a 25-page document and destroyed, it is page 7. That's one event. The second event is when a different page is randomly selected and ripped from the document. It is page 8. Well, I could check this with that 5% guideline. I have 2 pages that are going to be ripped out of the entire population, which is 25 pages. And if I check this, this gives me 8%, which is greater than this 5%. So I can't use that guideline and just say it's independent. So I need to decide if these events are independent. Well, hopefully it would make sense to you that the probability of ripping out the second page is going to change because one page has already been ripped out. So these are definitely dependent events. The second probability is going to change based off of what happened with the first event. Because these two events are dependent, because the occurrence of one affects the probability of the occurrence of. So the probability of the first page being selected, I select the first page out of the 25 total pages, I get 0.04. The probability of the second page, now really how this should be written is the probability the second page given that the first page has already been ripped out. So this is a dependent probability. This probability depends on the first probability. So how we say that in numbers is we're only picking one page again, but now there's only 24 pages because one's already been ripped out, and now we get this probability. Actually multiply these together, and you might say, well, that's what you did for the independent, but no, the independent probability just said take the probability of the first event times the probability of the second event. This is saying take the probability of the first event times the probability of the second event given the first event has happened. And this is very, very important that you understand this, because this probability can certainly be different if you have dependent events.
you doing, Mimi?